Hey everyone and welcome back to the channel. Today we're doing a complete review of one of the most fundamental parts of JavaScript, operators. Use them in every single line of code you write, but do you know all of them? Do you know how they really work under the hood? By the end of this video, you'll have a deep conceptual understanding of every operator in JavaScript, from the basics to the most modern additions. We'll cover the common pitfalls and the pro-level tricks that will make your code cleaner, safer, and more professional. Let's get started. Now, before we dive into the operators themselves, let's quickly define three core concepts. First, we have operands. These are the values or variables that operators act upon. Think of them as the nouns. For example, in 5 plus 10, the numbers 5 and 10 are the operands. Second, we have operators. These are the symbols that perform an action on the operands. They are the verbs. In 5 plus 10, the plus symbol is the operator. And finally, we have expressions. This is any combination of operands and operators that resolves to a single value. 5 plus 10 is an expression that resolves to the value 15. We can also classify operators by how many operands they take. First, unary operators. They work on a single operand. For example, the exclamation mark or not operator in exclamation is logged in flips one Boolean value, or x++, which increments a single variable. Next, binary operators. They work on two operands. This is the most common type, like a plus b. And there's one ternary operator in JavaScript, which takes three operands. We'll look at that one later. Okay, with that foundation, let's get into the first and most common group. The first category we will explore is the one you're likely most familiar with, arithmetic operators. These are the fundamental operators you learn in math class, and they form the backbone of any calculation in your code. And these are plus for addition, minus for subtraction, star sign for multiplication, forward slash for division, %sign for remainder or also called modulo operator, and star star for exponentiation, raising to a power. The remainder operator or modulo is particularly useful. It tells you what's left over after division. For example, with 10 modulo 3, you ask how many times does 3 fit completely into 10? The answer is 3 times, okay? And the leftover amount is 1. So the result is 1. Let's see them in a code example. First, I declare two numbers, const a equals to 10. Next, const b equals to 3. And now, let's add them. And I write const sum equals to a plus b. And let's see them in the console. Console.log sum. And if I run it, yeah, the output is 13. Next, the remainder operator, const remainder equals to a modulo operator %sign b and console.log remainder. We expect number 1 because 10 divide 3 equals to 3 and the remainder is 1. So if I run it, yeah, the remainder is 1. And the next one, exponentiation. Const power equals to b and 2 star signs, star sign, 2. This means 3 to the power of 2. So console.log power. What do you expect of this? 9. Okay, 3 to the power of 2 is 9. So if I run it, yeah, it's 9. Now we must cover a very important concept. The plus sign is a special operator in JavaScript because it has a dual identity, which is a major source of bugs for new developers. Here's the rule. The plus operator's behavior depends on the data types you give it. When both operands are numbers, it performs mathematical addition. If at least one operand is a string, it performs string concatenation. Concatenation is the technical term for joining strings together. The operator will convert the number operand into a string and then glue the two strings together. This behavior is critical to understand because data often comes from external sources, like a user. A golden rule of web development is that input from an HTML form field is always a string, even when the user types numbers. Let's see them. Here is a demonstration of the plus operator's two different behaviors. First, when both operands are numbers. So I write const result 1 equals to 10 plus 5. Semi and console.log result 1. What do you expect of this? Because both are numbers, plus operator will add these two numbers. And if I run it, yeah, 15 is the result. But if one of the operands is a string, what happens? Let's see it. So const result 2 equals to 10, but as a string. So I write double quotes 10 plus 5. And if I run it, boom, you got 105, but as a string. What happened? Before the operation, the number 5 is converted to the string 5 and then joined with the string 10. And as you can see, the result is 105, which is weird a little bit, but not for you anymore. To prevent this bug, you must explicitly tell JavaScript to treat the string as a number before performing the operation. The best methods for this are the number function or the unary plus operator, which is a shorthand for the same conversion. Let's see it. Now, alright, const user input equals to string 50 semicolon, and next const wrong total equals to user input plus 10 and console.log wrong total, and likely you can guess the result, okay, which is 5010. And next correct total equals to number with capital N, and inside the parentheses I write user input plus 10 and console.log correct total. This number function will convert the string 50 to number 50, and then the plus operator can add these two numbers correctly. And so if I run it, yeah, 60. And you know, there's another way to convert this string to number. Let's see it. Const also correct total equals to user input plus 10. Now to convert this string user input to a number, you can put plus before user input. And this will do the exact same thing like number function. And console.log also correct total. And if I run it, yeah, you can see the 60 again. Mastering the dual nature of the plus operator is a critical step in writing reliable JavaScript. Always be mindful of your data types to ensure your calculations behave as you expect. Continuing our exploration of operators, we now come to a convenient pair of shortcuts, the increment and decrement operators. These are known as unary operators because they act on a single variable. Their purpose is simple, to add 1 or subtract 1 from a variable's numeric value. However, they have one tricky feature that can catch new developers off guard. Their placement changes their behavior. You can place the operator before the variable, which means prefix, or after the variable, which means postfix. Here's the easiest way to remember the difference. Postfix, like x++, means use, then change. The expression evaluates to the variable's original value first, and then the variable is incremented. But prefix, like ++x, means change, then use. The variable is incremented first, and then the expression evaluates to the new value. Let's look at a practical example to see exactly what this means. So first, let me declare a variable. Alright, let postfix value equals to 5. Then, let postfix result equals to postfix value plus plus semicolon. When you put plus plus after the variable's name, it means it's the postfix increment operator. Next, I want to log this variables to the console. Alright, console.log, backticks, original value, colon, $, curly braces, postfix result. Next, console.log, new value, colon, $, curly braces, postfix value. And if I run it, postfix result is 5 and postfix value is 6. Let's break down this line. First, the program reads the current value of postfix value, which is 5. It assigns this original value to the new variable postfix result. After the assignment is complete, the postfix value variable is incremented by 1, changing its value to 6. So when the console.log functions run, postfix result prints 5 because it received the value before the increment happened. But postfix value prints 6 because it holds the new updated value. And now prefix example. Alright, let prefix value equals to 5. Next, let prefix result equals to plus plus prefix value. Now console.log prefix result. Next, console.log prefix value. Now let's break down this line of code. The program immediately increments prefix value by 1, so its value instantly becomes 6. After the variable has been updated, its new value, which is 6, is assigned to the prefix result variable. As a result, both variables now hold the same value. When the console.log functions run, prefix result prints 6 because it received the value after the increment occurred. Prefix value also prints 6 because it was updated before being used in the assignment. Now this exact same logic of use then change versus change then use applies perfectly to the decrement operator as well. X minus minus uses the current value before subtracting, while minus minus x subtracts first and then uses the new value. While this prefix postfix behavior is powerful, but it can also make code harder to read at a glance. To avoid confusion, it's often best practice to perform the increment or decrement on its own line of code. For example, alright, let my number equals to 10. And in the next line, alright, my number plus plus, semicolon. This clearly and simply changes my number to 11. And next, console.log my number. And if I run it, yeah, it's 11. Doing it this way makes your intention perfectly clear and reduces the chance of bugs caused by misunderstanding the order of operations. Now let's explore our next category of operators, assignment operators. Their primary job is to assign a value to a variable. The most fundamental operator here is the single equals sign. Now let's see how it works behind the scenes. When you write let x equals 10, the assignment operator performs a specific action. It evaluates the expression on its right-hand side, in this case, the value 10. It takes that resulting value and it stores it in the memory location associated with the variable on its left-hand side, the variable x. Think of it as a one-way street. The value flows from right to left. Now it's crucial not to confuse the assignment operator with the equality operators, like double equal signs or triple equal signs. The single equal sign, or the assignment operator, puts a value into a variable. You can read x equals 10 as x gets the value 10. But equality operators like double equal signs or triple equal signs, they check if two values are equal. They ask a question and return a Boolean value, like true or false. You can read x equals 10 as is x equal to 10. The real power of assignment comes from the shortcuts used to modify a variable's existing value. These are called compound assignment operators, and they combine a calculation and an assignment in one simple step. Now the first one is addition assignment, plus equals. This operator is used to add a value to a variable and update it. The rule is x plus equals y is a shortcut for x equals x plus y. Now, how it works. When JavaScript encounters score plus equals 50, it follows these steps. It looks at the variable score and gets its current value. It performs the addition using that value. The current value is 50. It takes the final result and assigns it back to the score variable, overriding the original value. Now first, let's see the addition assignment. So I write let score equals 100. Now I want to add 50 to the current value of a score. Now, how can I do this? I can write score equals to score plus 50, semicolon. But we can write this much shorter, and we can use the assignment shortcuts like this one. So I comment this out, and I write score plus equals 50, semicolon. This one does the exact same thing. Now let's see how it works. When JavaScript encounters score plus equals 50, it follows these steps. It looks at the variable score and gets its current value. It performs the addition using the value. Current value is 50. It takes the final result and assigns it back to the score variable, overriding the original value. And if I console.log score and I run it, yeah, we see 150. It added 50 more to 100 and assigns it back to the score. And this addition assignment operator works perfectly for joining strings. Let's see it. Let greeting equals to double quotes hello. And now I want to join this string with another string. How can I do it? I can write this. Greeting plus equals double quotes, comma, world, semicolon. And console.log greeting. And if I run it, yeah, we see hello world. It added the world string to the previous string. Next one, subtraction assignment. This operator subtracts a value from a variable and updates it. So if I write let player health equals 100 and player health minus equals 20 and console.log player health. When JavaScript sees player health minus equals 20, it performs these steps. It gets the current value of the player health variable. It performs a subtraction. Current value is minus 20. It assigns the final result back to the player health variable. And if I run it, yeah, it's 80. And next one, multiplication assignment. This operator multiplies a variable by a value and updates the variable with the result. So I write let total points equals 50. Next, total points times equals 3. And console.log total points. For an expression like total points times equals 3, JavaScript does the following. It gets the current value of total points. It performs the multiplication. Current value is times 3. It assigns the final result back to the total points variable. And if I run it, yeah, we can see 150 because 50 times 3 is 150. And next, 150 assigned back to total points variable. And finally, division assignment. This operator divides a variable by value and updates it with the result. So let items to share equals 40. And items to share divide equals 4. And console.log items to share. With items to share divide equals 4, the process is it gets the current value of the items to share variable. It performs the division. It assigns the final result back to the items to share variable. And if I run it, yeah, it's done. Okay, logic and comparison. This is where your code starts making decisions. These operators don't assign values. Instead, they compare two values and return a Boolean result, true or false. They're essential for controlling the flow of your programs. Now, strict versus loose equality. If you remember one thing from this section, make it this. Always prefer strict equality over loose equality. Now let's understand loose equality and strict equality. Loose equality. This operator checks if two values are equal, but will try to convert the operands to the same type before it compares them. This behind-the-scenes conversion is called type coercion, and it often leads to unpredictable results and bugs. And let's see how it works. For A equals B, JavaScript asks, can I make the types of A and B match? If so, are their values equal? This is why 0 equals false evaluates to true, which can be very confusing. Okay, now strict equality. This operator does not do type conversion. It checks for both equal value and equal type. If the types are different, it immediately returns false. This is safe, predictable, and what you should use 99% of the time. And let's see how it works. For A equals B, JavaScript asks two questions in order. Are the types of A and B the same? If not, the result is false. If the types are the same, are the values of A and B the same? The answer to this becomes the final result. Now let's see an example. First, let me declare some variables. Const number value equals to 5. Next, const string value equals to double quotes 5. First, I use loose equality. So console.log number value equals string value. And next, I use strict equality. So console.log number value equals string value, triple equals signs. And if I run it, yeah, the first one is true, but the second is false. And let's see another confusing example. So I write console.log 0 equals false. And next, console.log 0 equals false. The first one is loose equality operator, and the second is strict equality operator. And if I run it, the first one is true because this operator, loose equality, doesn't check for the types. But the second one is false because the strict equality operator checks for the types. Now, strict versus loose inequality operators. The same principle of avoiding type coercion applies to checking for inequality. Always use strict inequality instead of loose inequality. Loose inequality operator. This operator checks if two values are not equal, but also performs type coercion first. This can hide bugs again. For A exclamation mark equals B, it first tries to convert A and B to the same type, and then checks if their values are different. But strict inequality, this is the operator you should always use. It returns true if the operands are a different type or have a different value, but it does not do type conversion. Let's see how it works. For A exclamation mark equals B, JavaScript asks, are the type of A and B different? If yes, the result is true. If the types are the same, are the values of A and B different? The answer to this becomes the final result. Let's see an example. So I write const number value equals to 10. And const string value equals double quotes 10. And first, loose inequality operator. Console.log number value exclamation mark equals string value. And second, I use strict inequality. Console.log number value exclamation mark equals string value. And if I run it, the first one is false, which is a little bit confusing, right? but the second one is true. You should always use strict inequality operators. Let's see another example. Console.log 1 loose inequality operator true. And next one, console.log 1 now strict inequality operator true. And if I run it, the first one is false because 1 is coerced to true. But the second one, number type is not a Boolean type, and the type does not match. So the result is true. Now the next one is logical operators. Logical operators are the tools you use to combine multiple true or false values to make more complex decisions in your code. They're fundamental for controlling program flow. The first one is logical AND. The logical AND operator, or two ampersands, checks if the conditions on both its left and right sides are true. It only returns true if every single condition is met. Think about needing to get into a secure facility. You need a key card and a password. If you have the key card and the password, you can enter. If you have the key card but not the password, you cannot enter. If you don't have the key card but you have the password, you still cannot enter. It requires all parts to be successful. Let's see an example. So I write const has key card equals true. Next, const knows password equals false. Now, const can enter equals to has key card and, which means two ampersands, knows password, semicolon. And console.log backticks permission to enter, colon, $, curly braces, can enter. And if I run it, yeah, it's false because you don't know the password. Next one, logical OR. The logical OR operator checks if at least one of the conditions on its left or right side is true. It returns true if just one or more of the conditions is met. Think about paying for coffee. The coffee shop accepts cash or card. If you have cash or you don't have a card, you can still pay. If you don't have cash or you have a card, you can still pay. If you have both cash and a card, you can definitely pay. But you can only not pay if you have no cash and no card. It only requires one part to be successful. So, let's see it. And I write const has cash equals false. Next, const has card equals true. And const can pay equals has cash or, and here you have to put pipe sign, has card. And console.log backticks can the user pay, colon, $, curly braces, can pay. And if I run it, yeah, the result is true. Because it only needs one of the conditions to be true. Next, the logical NOT operator. The logical NOT operator is different. It doesn't combine two conditions. Instead, it inverts or flips a single Boolean value. It turns true into false and false into true. Think of a light switch. If a variable is light on is true, then exclamation is light on means the light is not on. So it evaluates to false. If a variable is door open is false, then exclamation is door open means the door is not open. So it evaluates to true. It simply gives you the opposite Boolean value. Let's see it. All right, const is tired equals true. Next, const has energy equals to exclamation mark, which means not operator, is, and then is tired. And console.log backticks, does the person have energy? Colon, $, curly braces, has energy. And if I run it, yeah, the result is false. Is tired was true, but the not operator act on it and turn it into false. So the person has not energy. Now, short circuit evaluation. The logical operators and or are more powerful than they look because of a behavior called short circuiting. This is an efficiency trick. JavaScript stops evaluating an expression as soon as it can determine the final outcome without needing to check the rest. This means these operators don't always return true or false. Instead, they return the actual value that stopped the evaluation. Before we start, remember that in JavaScript some values are considered falsy. Things like false, zero, empty string, null, undefined, and NaN. And all other values are trucy, like string hello, number 100, true, or an empty object literal. Okay, these are trucy. Now, the first one is logical OR. The OR operator evaluates from left to right and stops, returning the first trucy value it finds. If all values are falsy, it simply returns the last falsy value. Think of it like this. I need value A. Or if that doesn't exist, I'll take value B. We use logical OR for default values. This is a very common pattern to ensure a variable always has a valid value. So I write const username equals empty string. And next, const display name equals username or double quotes guessed semicolon. And console.log display name. Let's see what happens here. The idea here is display name gets the value of username, or if that's falsy, it gets guessed. Here, username is an empty string, so it's falsy. So the guess will be assigned to display name variable. So if I run it, yeah, we see the guess. Let's see how it works. JavaScript looks at username. Its value is empty string, which is falsy, okay? Because the first part is falsy, the OR operator knows the result depends on the next part. So it continues. It moves to the right, evaluates string guessed. This value is trucy. Short circuit. The operator has found its first trucy value. So it stops and returns that value immediately. The result is assigned to display name. Next one is the AND operator. The AND operator also evaluates from left to right, but it stops and returns the first false value it finds. If all values are trucy, it returns the last trucy value. Think of it like this. If this condition is met, and only then do the next thing. We usually use AND operator for conditional execution. This pattern is a concise way to run code only if a certain condition is met, acting as a compact if statement. Let's see it. I write const is logged in equals true. Next, I write a function show welcome message. Instead of parentheses, and next curly braces, and inside the write console.log double quotes welcome back. And after that, right, is logged in and show welcome message. Let's see how it works. JavaScript looks at is logged in. Its value is true, which is trucy. Because the first part is trucy, the AND operator knows the final result depends on the next part. So it must continue. It moves to the right and evaluates the expression show welcome message, which executes the function. So if I run it, yeah, you see welcome message because it's logged in is true. Then show welcome message will get executed. What if is logged in was false? If is logged in were false, a false value, the AND operator would short circuit immediately. It wouldn't bother looking at the right side, and show welcome message would never run. This makes it a safe and elegant way to conditionally execute code. Now, modern JavaScript power tools. JavaScript is always evolving, and new operators are added to solve common problems in a cleaner, more precise way. The first one is the Nullish Coalescing Operator. Remember how we use the OR operator to set default values? It has a common flaw. It triggers on any falsy value. This includes 0 and empty string, which are often valid inputs that you want to keep. The Nullish Coalescing Operator, or double question mark, was introduced to fix this problem. It's much smarter because it only provides the default value if the left side is null or undefined. That's it. It doesn't react to 0, empty string, or false. Think of the difference like this. The OR operator asks this question: is the value on the left falsy? If yes, use the default. But double question mark or nullish coalescing operator is the value on the left is specifically null or undefined. If yes, use the default. Okay, let's see why this matters with a practical example. Like tracking the quantity of a product in stock. A quantity of 0 is a perfectly valid number. First, we see the wrong way using the OR operator. I write let quantity equals 0. And next, const final quantity bad equals quantity or 10. And console.log final quantity bad. Let's see what happens. The variable quantity is set to 0. In a store's inventory, 0 is a valid and important value. It means out of stock, okay? The expression quantity or 10 is evaluated. The OR operator checks the value on the left, quantity. In JavaScript, 0 is considered a falsy value, along with false, empty string, null, and undefined. Because the left side is falsy, the OR operator discards it and returns the value on the right, which is 10. This creates a bug. The code incorrectly reports that the quantity is 10 when it should be 0. Now, what's the solution here? Using the nullish coalescing operator. Alright, let quantity equals 0. Next, const final quantity good equals quantity double question mark as nullish coalescing operator 10 and console.log final quantity good. Let's see what happens. Again, the quantity variable is 0. The expression quantity double question mark 10 is evaluated. The nullish coalescing operator is much more specific than OR operator. It only checks if the value on the left is null or undefined. It looks at quantity and asks, is this value null or undefined? The value is 0, which is not null or undefined. Because the condition is not met, the operator immediately returns the original value from the left side, which is 0. This is the correct behavior. It preserves 0 as a valid quantity. The example shows that you should use double question mark or nullish coalescing operator when you want to provide the default for missing values like null or undefined without accidentally replacing valid inputs like 0 or an empty string. Next one is optional chaining operator, question mark and dot. This operator is a modern and elegant solution to one of the most common errors in JavaScript. And the error is type error : cannot read properties of undefined. This error happens when you try to access a property on a value that is null or undefined. Optional chaining lets you safely attempt to access nested properties within an object. If any part of the chain is null or undefined, the expression immediately stops and returns undefined, instead of crashing your program. Think of it as saying, try to get this property, but if any parent along the way doesn't exist, just give me undefined and don't worry about it. Okay, this is the main idea. Let's look at the user object where some information might be missing. We want to get the user city, but the address property doesn't exist. So I write const user equals set of curly braces, and here I write my properties: name, double quotes, Alice, comma, details, and another object literal, set of curly braces here, and age, colon 30. The old and unsafe way. If you try to access the nested property directly, your code will crash. So I write const city equals user.details.address.city. And if I run this, yeah, it throws a type error because you're trying to read city from user.details.address, which is undefined, okay? Before optional chaining, you had to check every level of the object using the AND operator. It works, but it's long and hard to read. So let's see it. Const city verbose equals user and user.details and user.details.address and user.details.address.city and console.log city verbose. And if I run this, it doesn't throw an error, okay? But it returns undefined. And you might ask, what we're doing here? This code checks if user exists, then if user.details exists, and so on. As soon as it finds an undefined value, which is user.details.address, it stops and returns undefined. But there's the modern, clean way with the optional chaining. This is where optional chaining shines. It does the same exact thing as the verbose method, but in a much cleaner way. So let's see it. I write const city modern equals user. Now here you use question mark and dot. Okay, question mark dot. Details question mark dot. Next, address question mark dot city. And console.log city modern. And if I run it, yeah, it returns undefined. Let's see how it works step by step. User question mark dot asks, is user null or undefined? No, it's an object. So we continue. Next one is dot details question mark dot. Here we access user.details. It asks, is it null or undefined? No, it's an object. Object age colon 30. So we continue. Next one is dot address question mark dot. Here we try to access user.details.address. It asks, does this property exist? No, it is undefined. Now, because optional chaining encounter an undefined value, it immediately stops the evaluation. And the entire expression returns undefined. It never even tries to look for .city. Okay? This prevents the error and gives you a safe, predictable result with highly readable code. And the thing is, we can make optional chaining and nullish coalescing operators work together. These two modern operators are designed to work together perfectly. You can use them to safely access a nested property and provide a clean default value in a single, highly readable line. Optional chaining safely drills into an object. It prevents errors by returning undefined if any part of the chain is missing. And nullish coalescing operator takes a value and checks if it's null or undefined. If it is, it provides a default value. Combining them creates a powerful and safe two-step process. Step 1 is to safely try getting a value, and step 2 is to provide a fallback if that value doesn't exist. Let's look at an example where we want to find a user's city, but the address object might not exist. So I write const user equals set of curly braces name colon double quotes Bob. And notice here that no address details are provided for this user. And next, const city equals to user. Here I use optional chaining operator. Question mark dot address. And again, question mark dot city. And next, I use nullish coalescing operator. Double question mark. and double quotes, not specified, semicolon, and console.log city. And if I run it, yeah, we see not specified. Let's see how it works. This single line is executed in two main parts from left to right. First, JavaScript evaluates the expression to the left of the Nullish Coalescing Operator. It starts with user question mark dot address. It safely checks if user.address exists. It doesn't, so this part of the chain evaluates to undefined. Because it already found undefined, the optional chain stops immediately. And the entire left side, which was user question mark dot address question mark dot city, results in undefined. No error is thrown. Now, the expression has been simplified to const city equals undefined, double question mark, not specified. The knowledge coalescing operator looks at the value on its left, which is undefined. Now the expression has been simplified to const city equals undefined, knowledge coalescing operator, and string not specified. The knowledge coalescing operator looks at the value on its left, which is undefined. Since the value is undefined, the operator discards it and returns the default value on its right, which is string not specified. And this final value is assigned to the city variable. Together, these operators provide a robust and concise way to handle potentially missing data without crashing your program or writing complex multi-line checks. Next one is logical assignment operators. These are logical AND assignment, logical OR assignment, and knowledge coalescing assignment. These are introduced in modern JavaScript. These operators are powerful shortcuts that combine a logical check with an assignment. This allows you to write more concise code by performing a check and an assignment in a single step. An assignment only happens if the logical condition is met. Okay, the first one is logical OR assignment. This operator assigns a value only if the left side is falsy, like false, 0, empty string, null, and undefined. Think of it as if x doesn't have a real value, give it the default value of y. So let's see an example. This is perfect for setting a default configuration property if one isn't already provided. So I write const config equals an empty object literal. Next, config.timeout. Now I use logical OR assignment. 5,000. This checks config.timeout. Since it's undefined, a falsy value, it assigns 5,000 to it. Let's see it. Console.log config.timeout. And if I run it, yeah, you see 5,000. If config.timeout had already been set to a trucy value, like 1,000, this line would have done nothing. Okay, next, knowledge coalescing assignment. This operator is more specific. It assigns a value only if the left side is null or undefined. It ignores other falsy values like 0 or empty string. Think of it as if x is specifically missing, null or undefined, give it the default value of y. This is the correct choice when a falsy value like 0 is a valid intended value. So I write const settings equals set of curly braces speed colon 0. Next, settings.speed, and here I use knowledge coalescing assignment. So double question mark equals 75. This checks settings.speed. The value is 0, which is not null or undefined, right? Therefore, the condition is not met and no assignment happens. So let's see a console.log settings.speed. And if I run it, yeah, the value is 0. So the original value is correctly preserved. And finally, logical AND assignment. This operator works in the opposite way. It assigns a value only if the left side is true C. Think of it as if x already has a real value, update it with the value of y. This is useful for updating a variable only if it currently holds a true C value. Let's see it. Alright, const user equals an object literal syntax name colon double quotes Alice. And next, user.name, and here I use logical and assignment. So double ampersand equals double quotes Bob. And console.log user. And here user.name is Alice, okay, a true C value. So the assignment happens. If I run it, yeah, it's Bob. Next, const person equals curly braces name colon an empty string. You see, this person's name is an empty string. It's falsy, so we don't update it, okay? Next, person, the name, logical and assignment, double quotes, Charlie. Person, the name is an empty string, okay? A falsy value. So nothing happens, right? Let's see it. Console.log person.name. And if I run it, yeah, nothing happened because it was falsy. And logical and assignment signs when the left side is true C. Okay. And the next one is the specialist's toolbox, Bitwise Operators. You will likely never need to use these operators in typical day-to-day web development. You can safely skip this section if you're just starting out. However, if you want a more complete and professional understanding of JavaScript, or if you ever work on performance critical code, graphics, or data compression, then let's dive in. First things first, what is a bit? Before we look at the operators, we need to understand their perspective. Bitwise operators don't see numbers like 9 or 5. They see the raw data underneath. Think of a single bit as a light switch. It can only be in one of two states, on, which is 1, or off, which is 0. A bit is the smallest and most basic unit of data in a computer. To represent numbers, computers use a sequence of these bits. Let's see how the number 5 is represented in binary. You see the table, okay? This demonstrates how to convert a binary number, a number made of only zeros and ones, into its familiar decimal equivalent. Let's break it down. You see this place value, okay, 8421. Let's break it down. First, the place value. In our regular decimal system, we have place values like the ones place, tens place, hundreds place, and so on, okay? Powers of 10. In the binary system, the place values are powers of 2. Reading from right to left, the first place is the ones place, 2 to the power of 0. The second place is the twos place, 2 to the power of 1. The third place is the fours place, 2 to the power of 2. The fourth place is the eights place, 2 to the power of 3. And now the binary digit. This is the binary number itself. Each digit tells you whether to turn on its corresponding place value. A 1 means yes, include this value. And a 0 means no, skip this value. And now to get the decimal value, you multiply the binary digit by its place value and add them up. Like this, 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. And now you just add the results of the calculation, which is 5. So the binary number 0101 is equal to the decimal number 5. Now that we know this, let's see how the operators work on these sequences. First one is Bitwise AND. The Bitwise AND operator compares two numbers bit by bit. A bit in the result is set to 1 if the corresponding bits in both numbers are 1. This is often used to check if a specific bit is set. Let's see an example to understand. 5 in binary is 0101. And 9 in binary is 1001. Let's see how AND operator works with these numbers. Here you see the decimal numbers are converted to their binary equivalents. The bitwise AND operator compares the binary representations of the two numbers, column by column from right to left. A bit in the result is 1 only if the corresponding bits in both numbers are also 1. First column, the rightmost, 1 and 1 results in 1, okay? The second column, 0 and 0, results in 0. The third column, 1 and 0, results in 0. And fourth column, 0 and 1, results in 0. So the resulting binary number is 0001. When converted back to decimal number, 0001 is equal to 1. Now let's test our logic, okay? All right, const result equals 5. And here you have to use single ampersand, not double, just single. So, and 9. And console.log result. And if I run it, yeah, you see number 1. Next, the bitwise OR. The bitwise OR operator compares two numbers bit by bit. A bit in the result is set to 1 if the corresponding bit in either of the numbers is 1. This is often used to set a specific bit to 1. Let's see an example. And unlike the previous example, the number 5 in binary is 0101. And the number 9 in binary is 1001. The bitwise OR operator compares the two binary numbers column by column. A bit in the result is 1 if the corresponding bit in either of the two numbers is 1. First column, the rightmost, 1 or 1 results in 1. Second column, 0 or 0 results in 0. The third column, 1 or 0 results in 1. And the fourth column, 0 or 1 results in 1. The resulting binary number is 1101. To convert this back to a decimal number, you add the place values where 1 appears, 8 plus 4 plus 1, which equals 13. Let's test this logic again. Alright, const result equals 5. And here I use single pipeline symbol, okay, as bitwise OR operator. And 9, semicolon, and console.log result. Here we expect 13. Let's run it. And yeah, you see our logic is working. Nice. Next one is Bitwise XOR, exclusive OR. The Bitwise XOR operator compares two numbers bit by bit. A bit in the result is set to 1 only if the corresponding bits are different. This is often used to toggle a bit on or off. Let's see an example. Okay, the number 5 in binary is 0101. The number 9 in binary is 1001. The Bitwise XOR operator compares the two binary numbers column by column. A bit in the result is 1 only if the corresponding bits in the two numbers are different. If the bits are the same, both 0 or both 1, the result is 0. First column, the rightmost, 1 XOR 1 results in 0 because the bits are the same. Second column, 0 XOR 0 results in 0 because the bits are the same again. The third column, 1 XOR 0, results in 1 because the bits are different. And fourth column, 0 XOR 1, results in 1 because the bits are different. The resulting binary is 1100. To convert this back to decimal number, you add the place values where 1 appears. 8 plus 4, which equals 12. And let's test our logic. Const result equals, and here you have to use cat symbol, which represents XOR operator, 9. and console.log result. And if I run it, yeah, we see 12. Next is Bitwise NOT operator. The Bitwise NOT operator is unique because it works on only one number. It inverts all the bits. Zeros become ones, and ones become zeros. This one rarely used directly, but maybe part of some low-level algorithms. Now I want to use this operator on number 5. So I write const result equals. Here you have to use tilde symbol as the Bitwise NOT operator, okay? And number 5, semi, and console.log result. Before I run this code, I want to explain what really happens. Here, the operator first looks at the 32-bit binary representation of the number 5, which is 0, 0, 0, 0, and till the end is 1, 0, 1. The Bitwise NOT operator's job is to invert every single bit in the number's binary representation. This means all zeros become ones and all ones become zeros. So this number you see here becomes 1, 1, 1, 1, 1, 1 till the end and 1, 0, 1, 0. In JavaScript and most modern systems, negative numbers are stored using a standard called 2's complement. Because of how this standard works, inverting all the bits of a positive number x always results in minus parentheses x plus 1. The formula is minus parentheses 5 plus 1. And the final result is minus 6. The Bitwise NOT operator inverts the bits of 5, and JavaScript interprets the resulting binary value as minus 6. So if I run it, yeah, the console shows negative 6. Now the next one is the left-shift operator. The left-shift operator shifts all bits of a number to the left by a specified number of places. The empty spaces on the right are filled with zeros. This is a very fast way to multiply by powers of 2. This is really important in high-performance multiplication. X left shift y is equivalent to x times parentheses 2 to the power of y. Now, let's see an example to understand this. Now, I write const result equals 5. You have to put here double less than symbol and 1, semicolon, and console.log result. Before I run this code, let's see what happens. The operation starts with the binary representation of the number 5, which is 0, 1, 0, 1. The left shift operator takes all the bits of the number and shifts them to the left by a specified number of positions. In this case, it shifts them by 1 position. The original bits is 0, 1, 0, 1. After shifting left by 1 is 1, 0, 1, 0. A 0 is added to the empty space on the right. The new binary number is 1, 0, 1, 0. When converted back to a decimal number, this is equal to 10. A left shift is a very fast and efficient way to perform multiplication by powers of 2. The expression x left shift operator y is equivalent to calculating x times 2 to the power of y. In this example, 5 left shift operator 1 is the same as 5 times 2 to the power of 1, which equals 10. And if I run it, yeah, we see 10. And finally, the right shift operator. This operator shifts all bits of a number to the right. The empty spaces on the left are filled using the original leftmost bit, the sign bit. This preserves whether the number is positive or negative. It's a fast way to divide by powers of 2 and discard the remainder. And the use case is high performance integer division. Let's see an example. Here I write const result equals 9 and double greater than sign 1. Console.log result. Before I run this code, let's understand it again. The The process begins by converting the decimal number 9 into its binary form, which is 1001. The right shift operator takes all the bits of the number and shifts them to the right by a specified number of positions. In this case is 1. Okay. The original bits is 1001. After shifting right by 1 is 0100. During this shift, the rightmost bit, 1, is discarded. For a positive number, a 0 is added to the empty space on the left. Now, the new binary number is 0100. When converted back to a decimal number, this is equal to 4. A bitwise right shift is a very fast and efficient way to perform integer division by power of 2. It's like dividing by 2 and rounding down to the nearest whole number. As the comment shows, 9 right shift operator 1 produces the same result as math.floor 9 divided 2, which is 4. Okay, and if I run it, yeah, we see 4. Finally, there are also bitwise assignment operators, which combine a bitwise operation and an assignment, just like the logical and arithmetic assignment operators we saw earlier. And now, the rules that JavaScript uses to solve expressions with multiple operators, a concept known as operator precedence. Now, operator precedence asks which operation goes first. Just like in standard mathematics, JavaScript has a built-in order of operations. This set of rules, called operator precedence, determines which operators are evaluated first in an expression. A key example is 10 plus 5 times 2. Multiplication, or that star symbol, has a higher precedence than addition. Therefore, JavaScript calculates 5 times 2 first, which results in 10. Then it performs the addition, 10 plus 10, giving the final answer of 20. Now, the thing is, what happens when precedence is the same? When an expression has multiple operators with the same precedence, associativity determines the order. Most operators like division and multiplication are evaluated from left to right, which means left to right associativity. They have left to right associativity. In the expression 100 divides 10 divides 2, JavaScript first calculates 100 divides 10, which is 10, and then calculates 10 divides 2, giving 5. And now, right to left associativity. The main exception is assignment operators, equals plus equals. They are evaluated from right to left. That's why A equals B equals 5 works. The B equals 5 operation happens first, assigning 5 to B. Then the value of the expression 5 is assigned to A. The full precedence table in JavaScript is long and complex, and you don't need to memorize it. And the most important rule is to use parentheses to make your code clear and force the order of operations you intend. Parentheses have the highest precedence of all. So let's see an example. First I write const tool equals 10 plus 5 times 2. This code is ambiguous, okay? It's not clear what you intend to do. This relies on someone knowing the precedence rules. Next one is clear code. I write const clear code equals 10 plus, and here I open up a set of parentheses. And inside that I write 5 times 2. The parentheses make it obvious that 5 times 2 should be calculated first. And next one, I want to force a different order. So I write const force tool equals, and here I open up a set of parentheses. Inside it I write 10 plus 5, and next times 2. Here the parentheses force addition to happen first, and then the multiplication. So if I run this code, yeah, the first one is 20, and the next one also 20, but the last one is 30 because the order of operation has changed. And that's our comprehensive tour of JavaScript operators. We've covered a lot, from the absolute basics to the modern power tools. Thanks for watching. If you found this video helpful, please hit the like button, subscribe, and let me know in the comments which operator you found most interesting. See you in the next one.